You have to learn about concept of friction. Friction is not easy. Friction. Friction has so much concept inside. I just gave you one formula, right, about friction. What is friction? What is friction?
Mu n.
Mu into n, correct? Friction is mu into n. What is mu?
Coefficient of friction.
Quotient of friction. That means the roughness of the surface. Okay, surface will be how much rough. They'll have value 0.1, 0.2 like that. They will have values. Okay, surface based on surface. Mu is 0.2 means more rough. 0.3 means even more rough. Got it or not? Quotient of friction. It will be, you will get below 0.5 or you will get below 1 only always. More than that, you won't get. Clear, ma? Yeah. So, what's happening here? What is this video is telling? Here itself, full concept is the friction. In this video itself, full concept is there. If you understand this video, then done. I'm done with friction. It looks so simple video, but there is lots of concept in that. What is that? B is applying force on the object, correct or not? When it is applying force on the object, initially it is not moving, correct or not, ma? Initially it is not moving. Okay. What is green arrow suggesting? What is green arrow? This green arrow, what is it? What is it indicating?
The force applied.
Applied force, correct or not, ma? Green arrow is indicating. This green arrow is indicating applied force. Clear or not? What is that red arrow indicating?
Friction.
Friction, correct or not? Any doubt in that? They are doing small, very small, like they are trying to convey something in the video by moving the arrow marks. Anybody? Then
So
trying
the
to
applied
something.
force has to overcome friction to move.
Yeah, applied force is what is happening to applied force? It is increasing, correct or not? It is increasing. When you are applying applied force, proportionally, what is increasing?
Friction up to a point.
Friction is also increasing, correct or not? Correct or not, ma? Sir, how do you know it's increasing? Arrow marks, ma, I'm telling based on the arrow marks. Arrow mark length is increasing, right? Applied force length is increasing. This arrow mark length is increasing. This arrow mark length is also increasing, correct or not? If applied force value is increased, then frictional force value is also increased. First point, you need to understand that. Clear or not? Yeah. Suppose if they give object, see now I'll apply that concept first. See, I'll ask some questions. There is a block resting on 5 kg block resting on the focus my ear to copy fast. There is a 5 kg block resting on the surface whose quotient of friction is 0.2. Whose quotient of friction is 0.2. Clear or not? Whose quotient of friction is 0.2. How much frictional force will be acting on it? What is the amount of friction acting on it? What is the magnitude of friction acting on it? 5 kg mass, I kept it on the table, ma. Having quotient of friction 0.2. Mu value is 0.2. How much frictional force will be acting on it?
10 Newton.
How much frictional force will be acting? She told 10 Newton. Anybody else? Friction force formula is what, ma? Frictional force formula is?
Mu n.
Mu n. Sir, you didn't give me n value. I didn't give you n value, but n is how much?
50.
N is how much, ma? N will be? N will be?
50.
N will be mg. Why?
Gravitational
Because it's
force.
not moving along the y-axis.
Y-axis direction, net force will equal to 0. Very important point. N is not always mg. N is not always mg. I repeated that point many times. Correct or not? N is not always mg. In this situation, N is mg only. Okay. In this situation, N is mg only, ma, but not all the time it is mg. Be careful. I'll tell you different situations. Okay. N is mg. So what did you do? Listen properly. So what did you do? N you got mg. I didn't give you n value, but how did you calculate n value? How did you calculate n value? How did you calculate n value? Tell ma, how did you calculate n value?
By multiplying mass with 10.
Mg, right? You did mg. So 0.1 into 5 into 10 you did. Correct or not? How much it is?
It was
0.2 I gave. I gave 0.2. Okay. 0.2 into 5 into 10. Okay. So answer how much you are telling? 10 Newton. Correct or not? Okay. Friction is not that easy. Ma. So what you did, you applied formula. Correct or not? You applied formula. But you know, answer is 0. Answer is what, ma? 0. 10 is wrong. 10 is wrong. Okay. Why I will tell you. Why I will tell you. See, B is not applying force on it, correct or not? When friction will come into the picture means if you try to move it, friction will come or else it won't come. Correct or not, ma? If you apply force, then only friction will come. What is the question I gave you? Did I say am I applying any force on it? What is the question I gave? I gave 5 kg body resting on the 5 kg body resting on a table having quotient of friction 0.1, correct or not? How much frictional force acting on it means 0 because there is no applied force. Clear or not? Clear or not, ma? If you apply force, then only friction will act, ma, or else it won't act. Newton law will go wrong, no, ma. Newton law will go wrong. You are telling only friction is acting. See, right now B is not applying force, correct or not? Right now B is not applying force. Then how much friction force should be there on it? How much friction force according to you? 10 Newton should be there on it, correct or not? That means it should move left side, no? There is no other force, right? Horizontally. There is no other force horizontally. That means it should move left side, no? One force is there, then it should definitely move, right? With acceleration 2 meters per second square. Clear or not, man? Newton's law will go wrong if you think friction is there before applied force. You don't have to think that much. If you want to remember simply, what is the point I am conveying? Tell ma. What is the point I conveyed simply?
Friction is there only when applied force.
Applied force. If applied force is not there, then friction will be 0. If something is resting on the table, without applying any force, ma. Sir, how much force I should apply? Should I apply in such a way that it should move or it should not move? When friction will come into the picture means as soon as you start pushing it, friction will come into the picture. Got it or not? As soon as you start pushing it, friction will come into the picture. If you touch it, friction will come. Or else it won't come. Clear or not? My first point is done or not? Yeah. See here, even graph also conveying that thing only. No, graph where it started, tell me. Where is the point the graph is starting? X-axis is applied force, ma. Okay, X-axis is applied force, Y-axis is friction. Let's take Y-axis as friction. Then, where is it starting? Graph. At what point graph is starting?
0.
0, 0, correct or not? What does that mean? It's starting from origin, no? What does that mean?
When applied force is 0,
When applied force is 0, friction should be 0, right? Clear? Any doubt? Next question. First question clear, right? First question answer is how much, ma? First question answer is how much?
Friction is 0.
Yeah. 5 kg body resting on a table which is having a quotient of friction on 0.2 Newton, quotient of friction 0.2 Newton. I applied a force of 5 Newton. I applied a force of 8 Newton. What is the amount of friction acting on it? Frictional force is how much? Now friction force will be there, correct or not? Why it will be there now friction? Now why friction will be there, no?
Because there's a force acting on
There is a force acting on it. That's what I told. No, if force is not acting on it, then some applied force should be there. Then only friction will be there. Okay. Or else it will not be there. I applied 8 Newton force. I am saying friction will be there now. So how much is the friction force acting on it now? Tell.
8 newtons.
How much is the friction force acting on it?
8
Yeah,
newtons.
good. 8 Newton. Now also you should not tell 10 Newton. Understood or not? Now also you should not tell 10 Newton. That mu mg will calculate, right? That also you should not tell. Now also you should not tell. Answer will be how much, ma? 8 Newton. Sir, how, sir? You didn't understand. I'll give you only one statement. One statement I'll tell, okay? You're applying force, right? You're applying force, right? How much force you have to apply to move this fellow? To move this 5 kg, how much force you need to apply? To move 5 kg, how much force you need to apply?
More than 10 Newton.
More than 10 Newton you have to apply, no, ma, because you calculated friction. No, how much it came? 10 Newton, correct or not? If you apply 1 Newton, will it move? If you apply 1 Newton, will it move, ma? It will not
No,
move.
sir.
If you apply 2 Newton, will it move? It will not move. If you apply 5 Newton, will it move? It will not move. If you apply 8 Newton, will it move? It will not move. If you apply 11 Newton, it will move? It will move, correct or not? So simply what I am telling is, simply I told I'll give you one statement. No, if F applied is less than that static, maximum static friction, whatever you calculated value, 10 Newton. Okay, if you apply force less than that, then friction will be equal to applied force only, ma. Friction will be equal to what? Applied force. Clear or not? Friction will be equal to applied force. That is what these arrows are conveying. These arrows are conveying the same thing. See, applied some force, right? Initially, he applied some force. Okay. How much he applied? Let's say he applied with the length of the vector, we'll say. Let's say he applied 2 Newton. How much friction force is acting on? 2 Newton only. Got it or not? Next, let's say he applied, now he increased the force, correct or not? He increased the force to 3 Newton, correct or not? Still, this will be also 3 Newton only. Both the arrow marks length same, no more. Until it starts moving, what is the statement I gave? Until it starts moving, friction force will be equal to what, ma?
Applied.
Applied force, that's it. Just remember it like that. Until it starts moving. Sir, how will I know? How will I know will it move or not? How will you know, ma? How will you know when it will move? How will you know at what force it will move?
When F static is
You have to calculate mu mg. There is no other way. You have to calculate mu mg. Okay, you have to calculate mu n value and see whether it is whether the applied force is greater than friction or not. If it is not greater than friction, whatever applied force is there, same answer you have to give. You should not give 10 Newton. How much applied force I gave? How much applied force I gave? Applied force, how much I gave, ma?
8 Newton.
8 Newton. So friction force will be
8 Newton.
8 Newton only. Why? Because it is not moving. How do you know it is not moving? How do you know it is not
Because it
moving?
doesn't surpass 10.
Friction force is 10 Newton and you are applying 8 Newton. How it will move? It won't move. No. Right now it is moving. B is able to move it. Not able to move it. Correct or not? When it is able to move it, it is able to move it when it applies the maximum static friction value it will apply. No, that time only it is able to move it. Correct or not? Clear or not, Mo? That's why graph, no, till here graph, how it comes, Ma, exactly? How graph comes exactly till here? It will come exactly in 45 degrees. Why 45 degrees? When 45 degrees will come straight line? Y equal to x line only, no, Ma? Y equal to x line when it will come? 1, 1, 2, 2, 3, 3, 4, 4. That is what happening. No, if F applied is 1 Newton, friction is
1 Newton.
1 Newton. If F applied is 2 Newton, friction is
2 Newton.
answer my, you have to answer my, come on, then only this concept you need to understand. This is the only place where you can understand. Come on. F applied is 3 Newton, then friction is tell
3
3
Newton.
Newton.
3 Newton. Sanjana not speaking. Aditya not speaking. Arpita not at all speaking. You know what will I do if you don't speak? Tell me next. If I applied force is 4 Newton,
Friction's 4.
friction is 4 Newton. If F applied is 8 Newton,
Friction
friction
is
is
8.
8 Newton. If F applied is 11 Newton, then friction is
10.
10 Newton. If F applied is 20, then friction is
10.
10 only, Ma. Correct or not? If F applied is greater than friction value, then what will happen? You are calculating, no, mu mg value, that is only answer. Correct or not? See, it has applying, no, after certain time that red arrow mark is not increasing. Correct or not? See, it applied, red arrow mark increased. Once it started moving, red arrow mark will be constant, green arrow mark will increase. Even the graph also, what it is saying? What graph is saying? Once the value reaches,
Friction will be constant.
friction will be
Constant.
constant. Correct or not? But applied force can be increased or you can keep it same, your wish. But what B is doing? It is applying more force, but still friction value is not
Constant.
increasing more than that certain value, that 10 Newton. Clear? Any doubt?